I'm going to go ahead and zoom it up. So number 1 is exactly like the ones we did yesterday, right? You just have to, you have a number of ways of solving them, right? This one is easy to graph. You can do a t-chart and graph it. This one you can find your intercepts. I don't care how you find it and how you graph it. You can put it into slope-intercept form. You can find intercepts and graph it. You can use a t-chart. That's up to you. We're going to do number 2 because number 2 is a little special. All right, so looking at number 2, I have 2 equations. I prefer putting it into slope-intercept form, which you guys have done. So we're going to review some of what you did last assignment. It's just less work. So I'm going to take this first equation, 2y equals negative x plus 6. And this is pretty much already in slope-intercept form. Remember, slope-intercept form is on my wall. It's y equals mx plus b. All I need to do is get rid of this 2 here. So I'm going to go ahead and start by dividing every term by 2. And that's going to give me y is equal to negative 1 over 2x plus, what's 6 divided by 2? 3. Now some of you guys are going, wait, where'd you get that negative 1 from? What's in front of this x? There's 1, right? He's hiding. So it becomes a negative 1. Okay? So for this first equation, I know that my m is negative 1 over 2, and my b is positive 3. Okay? So now I can do my second equation. Negative x is equal to negative 6 plus 2y. Now this is definitely not in the order that I need it to be. Do you plan on doing any work? Looking at you. Yes, I'm looking right at you. You're right up here. Lost and found. Grab will make it work for you. So I'm going to go ahead and change the order of this, right? On this side, I need that y, right? And I need the x over there. So I'm going to use multi-step equations to make that happen. Okay? I'm going to go ahead and do the opposite. What's really in front of this x? So I'm going to go ahead and I'm going to add the opposite of this, plus 1x. And I'm also going to add it to this side. That makes my new equation. This becomes a 0, negative 6. But before I put down this negative 6, I'm going to think about the order that I actually want it to be in. What do I want to be first after my equal sign if I'm putting it into slope-intercept form? Don't worry about him, Carissa. He's a big boy. He can take care of himself. Yes, you do. So what am I going to put first? Don't look at him. Up here. Entire class. All right. What do I want first? Grant, you said something right now. Why do I want to put negative 6 first? So what do I want to write first? Plus 1x or just 1x, right? Now when I write, what's next? Minus 6. And then? Plus 2y. And the reason I want it in that order, because I'm going to move this y over here, but I want my x and my b, right? mx plus b. So now, how do I move my 2y? Not divide. I need to move it over here. So I want to do the opposite, right? So I'm going to add or subtract 2y from both sides. So as I bring down my equation, now I have negative 2y is equal to x minus 6, or 1x minus 6, right? Because this became 0 as I moved it to the other side of the scale. Now how do I undo this here? Angel? So I'm going to divide every term, okay? Not number, because this is a term. By what number? What number?
2y.
What number?
Negative 1.
Negative 2. Thank you, Angel. So this becomes y, and that's y by itself. What is my slope going to be? Christian?
What's the slope going to be?
Mm-hmm.
The slope is going to be...
What do I do with this?
You're dividing it?
Yeah. Can I divide 1 by 2? I can? Don't look at me. Look at the problem. What's my answer? How do I fix? What do I write?
What?
No.
Negative 1. Negative 5.
Christian? I'm still talking to Christian. How do I write this? That's already written like that. How do I write my answer? What am I going to bring down? My 1x? What about the 2? Actually, it's a negative 2. Angel, you want to help him out?
Yeah.
What should I bring down?
1x over 2 negative 2.
Remember, this is what I'm looking for.
Oh. Y equals 1x.
I want this to be separate from that. So what do I bring down? Karina, you want to give it a shot?
Bring down the 1 and the negative 2.
Okay. Do I want that negative 2 on the bottom, though?
Yes, I can do that.
Where do I want it? I want it on the top. So I'm going to bring up 1 over 2. And then my x tags along. Now I have a negative 6 divided by a negative 2. What kind of answer is that going to give me? A positive 3. Okay, so now for this problem here, I have m is equal to negative 1 over 2, and b is equal to what?
3.
Okay, so my starting point for both of these is going to be 3. Let's look at this really quick, though. Look at this problem here. I put into slope-intercept form, what does it look like? It says y is equal to negative 1/2 x plus 3, right? What about my slope-intercept form for this one? What is it? It's identical, isn't it? So if I graph these lines, what kind of lines am I going to have?
Straight line.
Well, let's graph them, okay? Let's just see what that gives me. So my starting point is going to be positive 3, right? My graph is negative 1 over 2. So negative 1, right 2, right? Negative 1, right 2. All right, so let's go ahead and graph that and put that line there. Now I'm going to graph this one. What's my starting point?
3.
3. So I'm going to go here. Here's 3. And what's my slope?
Go down 1 and over 2.
Down 1, right 2. Oh, look. Down 1, right 2. Wait a minute. What do you know about my lines? Shouldn't I have 2 lines? Do I have 2 lines? Why not?
Because they're both the same.
They're identical, right? So that tells me this is a special problem. That tells me that the line of both of these equations are very special in that it creates infinitely many solutions. Infinitely many solutions. That means any number you plug in will work to solve these problems. And every time they're going to be identical. This will be the graph of that line. Okay, special problem. It's still doing what we did before, but this time your answer is a little different. So what we want to look for when we have infinitely many solutions, they're going to have the same slope and the same y-intercept. So infinitely many solutions will have same slope, same y-intercept. That's going to give you infinitely many solutions. So that's one of your special problems. We have another special problem. So go ahead and flip your paper over. And we're going to look at number 5. So again, this time we can do pretty much anything we want. And for this problem, like I said, I've taught you several ways to graph this, okay? For this one, I'm going to use my y-intercepts. So x-intercept when y is equal to 0. Y-intercept when x is equal to 0. Okay? So I'm going to take this problem here, and I'm going to rewrite it. And I'm going to do that for both lines. So you guys should know how to solve this problem. We're going to start with this one here. Y is 0, so I have x minus 3 times 0 is equal to 6. If I'm solving this problem, this eliminates, right? So x is equal to 6. So the ordered pair for this one is going to be 6, 0. On this side, this time we have x is equal to 0. So I have x minus 3y is equal to 6. That is a 0. All I need to do is divide both sides by this negative 3. And then I get y is equal to negative 2. My answer is going to be 0, negative 2. I can graph this line now. I'm just showing you another way of finding how to graph these lines. There are many different ways. I'm doing several different ways so that you can figure out which one works best for you. So I'm going to go ahead and graph it now. Here is 6, 0, which is off the chart up here. This is 0, negative 2. So my line is going to be somewhat like this. All right? That's this problem here. Let's do the next one. For this one, I'm going to use a T-chart method. Okay? So I'm going to say my T-chart here. I'm going to look at what's in front of that y, and I'm going to use it for my x value. Negative 3, 3, and 0. Okay, and then I'm going to substitute these numbers into this equation to find my line. So I'm going to say negative 3 is equal to 9 minus 3y. Why did I do negative 3? Because it's already a negative. And my x is a negative 3. Right now, because I am subtracting a negative. So this, in turn, becomes positive. So now I have a plus 3. Anytime you have minus a negative, it becomes a plus 3. It becomes a positive. So I can solve this problem in one of two ways. I like my y on the left, so what I'm going to do is I'm going to go ahead and I'm going to change the sides that my information is on. I can swap sides without doing anything because it's still balanced. All I did was change the side of the equal sign. My scale is still balanced. So I'm going to go ahead and subtract this 9, right? Minus 9 from both sides. That's going to give me a negative 3y is equal to what? What is 3 minus 9? It is a negative 6. Now to solve for y, I need to divide both sides by what number? Negative 3. So y is equal to negative 6 divided by negative 3, which is going to give me a positive 2. So here my y is going to be positive 2. My next problem, I'm going to go ahead and work on. I have negative x is equal to 9 minus 3y. This time my 3 is going to be a positive 3. But it's not a negative 3, so I can just write minus 3 is equal to 9 minus 3y. Once again, I'm going to switch my sides. So I'm going to say 9 minus 3y is equal to negative 3. I just like it better on that side. I'm going to subtract 9 again. Subtract 9 again. This time I have negative 3y is equal to what? A bigger negative, which is going to be what? Negative what? Negative 12. Divide both sides by negative 3. What does y equal now? Positive 4. Okay. For the last one, x is going to be 0. So write it out over here. It's going to be easy. 0 is equal to negative 0 is still 0. 9 minus 3y. All right. So I'm going to switch my sides. 3y, or 9 minus 3y, sorry, is equal to 0. Subtract 9, subtract 9. Now I have negative 3y is equal to negative 9. Divide both sides by negative 3. What does y equal? What does y equal? Positive 3. Right? So I can go ahead and graph that now. All right? So my values are negative 3, 2. So from 0, negative 3, positive 2. From 3, positive 4. From 0, 3. So when I graph this line with the points that we have, what do you notice about the two lines? They're not identical because they're not on top of each other. What would we call them? What mathematical term can I use to describe these lines? Say it again. They are parallel. Will they ever touch?
No.
Parallel lines will never touch. They will go on for infinity without crossing each other. So that is also a special problem or a special solution. What do you think the solution would be to this system of equations? Will they ever touch? So will there be an answer?
No.
So the answer will be no solution. So when you have a parallel line, you're going to have the exact same slope. Same slope. But you're going to have a different y-intercept. So the slope is going to be the same for these guys, but where they start and where is going to be a different spot. They're going to be two parallel lines on that grid. Okay? Two special answers. If I put these into slope-intercept form, might have been easier for me to find that they had the same slope. You can do slope-intercept form, you can do t-chart, you can do x and y intercepts. 3 different ways to graph those lines. You pick which one works for you, which one is easiest for you, and then do that. You have 6 more problems to go. Get to work on them.